So we're going to solve the IB style practice questions from concepts involving scientific notation, rounding, approximation, and error. So number 1 asks us to calculate this particular expression. Remember, you are allowed a calculator on every single one of your assessments, quizzes, tests, exams, including the real IB exam. So of course we're going to reach for our calculator here. 3.7 times 16.2, and they're really checking to see that you can use the square button on your calculator here, which is right there. And then we'll subtract 500. And it says that we should write our answer correct to 2 decimal places. So, whoops. Okay. So to correct to 2 decimal places, so here's our original number, 471.028. 2 decimal places means that we simply count 2 places after the decimal, and that will be our cutoff to the number. So we need to look at the number just to the right side of the cutoff. Since it is 5 or greater, this 2 will round up. And so it becomes 471.03, and now that is written to 2 decimal places. I just want to point out that some of you might know how to use this button here on your calculator, an exponent, and I'll show you what happens if you have the new operating system installed already. Then you need to be careful using that button. 16.2 squared. Oh, sorry, that's exactly what I did not want to do. Okay, come on. I'm trying to get rid of that, there we go. Alright, 16.2. And we go to the power of 2. And you'll see that I'm now still the power of 2. If I just write now minus 500, it will appear as a part of the exponent, and 2 minus 500 is negative 498. So I'd be taking 16.2 to the power of negative 498 instead of 2. So let's go back a bit. And when you're in the exponent and you've just written your 2, let's say, and it's got this flashing cursor to the right, and by the way, if your calculator does not look like mine right now, it must be because you do not have the new operating system installed. So, alright, here we go, 16.2 squared. You need to press the button to the right. And now then we have exited the exponent and we can subtract 500, and you already know the answer. Alright, part B. We need to round the number correct to 3 significant figures. So our original number was 471.028. Significant figures have nothing to do with the decimal point. For significant figures, we're going to count through the number from left to right until we reach a non-zero number. Now in this case, our non-zero number is right at the very beginning, a 4. So that will be our first significant figure. This will be our second, this will be our third. So if one of these had been a 0, it would still be significant because we start counting our significant figures from the moment that we find our first non-zero significant figure. And so any numbers afterwards will now be significant, and we'll go, in this case, 3 in a row, 3 significant figures. This will be our cutoff. And we look at the number to the right of the cutoff, and because it is less than 5, we will not change that 1, and it will round to a 471, and then everything afterwards becomes zeros. In this case, I should not write 0.000, of course, otherwise I'm implying that those 3 extra zeros on the end are also significant. Part II in what we would call the scientific notation. The IB is careful not to use this term, scientific notation, because of, I guess, international standards. There might be some countries that would refer to that as something different. So they give you the form, a times 10 to the k. We know that a is a number between 1 and 10. We know that k is an integer. So so we're dealing with 471.028. And we're not rounding this time, we're actually writing the exact value. And that's why I'm not using these crooked or curly approximately equal symbol. I'm using a straight on, this is exactly equal. And for scientific notation, a little bit like significant figures, we first look for the first non-zero digit. We know that this is at the beginning, the 4. And so our decimal point must go immediately after the 4, and that's how we ensure that A, the number in front, is going to be between 1 and 10. In this case, of course, we've got 4.71028 is the complete number. And how many times did I move the decimal place? 1, 2. And so it's times 10 to the, there's going to be a 2 in here, and because I moved the decimal place to the, because this is a large number, this is going to be a positive exponent. Okay? Number 2. Oh, sorry, let me just flip over to the mark scheme so that you can have a look and see how the IB awarded marks for this work. And so, there, they've rounded to 2 decimal places, and they got 1 point. And then in part I, getting 471 to 3 significant figures is also 1 point. And then writing it in scientific notation, this is a little bit interesting, I think. They would accept the answer to 3 significant figures, or they would accept the original value, and that's how I interpreted the question. Or they would even accept that you rewrite your answer to part A, the one that's been rounded to 2 decimal places. If we converted that into scientific notation, they'll take any of the 3. And it doesn't say so here, but I know this from experience, that the first answer mark is awarded for writing, say, in our case, 4.71028. So having moved the decimal place to the right place immediately after the first non-zero digit, and then the second number would be for writing times 10 squared. Alright, back to number 2. A girl's height is 1.623 meters. Write her height to the nearest centimeter. Now then, I hope you know that centimeters, we've got 100 centimeters in a meter. And so, what's going on here is that we're dealing with 1 meter and 62.3 centimeters. And so, that would be one place to start, I suppose, is that we could rewrite this amount in centimeters by moving the decimal over twice. And then, of course, this is going to be approximately equal, as I round to the nearest centimeter, 162 centimeters, because our cutoff is right here and the number to the right is lower than 5. Part B. The time taken to fill a tank, 2 hours 43 minutes. Write this time to the nearest 5 minutes. So when it says the nearest 5, it means that we're counting in 5s. 5, 10, 15, 20, 25, 30. And let's keep going. 35, 40, 45. Clearly, 43 is closer to 45 than it is to 40. And so if we're going to round this to the nearest 5 minutes, we'd have 2 hours and 45 minutes. And I suppose that you could also write this in minutes. We know there's 60 minutes in each hour, so that must make 120 minutes in 2 hours, plus 45 minutes is a total of 165 minutes. I'm guessing that IB will accept either of these answers, but we'll see in a minute. Part C, the attendance at a show, 2,591 people. How many people to the nearest 100 are at the show? Okay, so to the nearest 100. That's our ones place, tens place. Here's our hundreds place. And so that's going to be our cutoff. We're rounding immediately after the 100s place. The number after that 5 is a 9. That's bigger than 5, and so we must round that 5 up to a 6. And then everything after our cutoff becomes zeros. 2,600 is the nearest 100. And part D. The mean distance of the moon from the Earth is approximately 384,403 kilometers. Write this distance in, we know this is scientific notation. And so let's do, we'll look for the first non-zero digit, which is a 3. And that's where our decimal place will come immediately afterwards, 3.84403, as I continue the number. How many times did I move the decimal place? Let's see. If I knew it had to end up here, I moved it 1, 2, 3, 4, 5 places. Is it a positive 5 or a negative 5? Well, because our number is a very large number, it must be a positive 5. And let's just check the mark scheme. So you'll see that it accepted either the answer in centimeters or the answer in meters. There we go. And again, like in part B, also worth 1 mark, it accepted it in hours and minutes or purely in minutes. Part C was also worth 1 mark. And part D, you can see that they would have also accepted an answer where it had been rounded to 3 significant figures, as opposed to the entire number. But they'll take either answer.